joining this meeting. Okay, what I do is that yeah, this is the interactive session. You can ask anytime question. Okay, we are having enough time. Okay, a few participants are there, and whatever you are having doubts and other things, you can ask. And later also you can interact, and you can send to me or the Sci-Fi will. Okay, we'll try to address your doubts, and also okay, if it is possible, we will mentor you as well. Okay, if it is need is there. Okay, so in this brief discussions, what I am doing is that I am taking you through the power and communication architecture of EV. Basically, that we need to understand the other things better. And then taking you through evolution, how basically automotive industry has evolved, particularly because this is with respect to the four-wheelers. And what this EV is giving the technical challenges and how, okay, what is its future? And then with respect to India, particularly with so many vehicles coming on Indian roads, particularly the light EVs, what we call the L2 and the L3 category of vehicles. So I'll be touching upon the AIS-156 and okay, what are those challenges and what we faced last year, what are those issues and other things. So those things I'll be touching. Okay. So yeah. So this is a basic EV architecture. So the glider part I am not taking here. Glider will remain same, whether it is a four-wheeler, three-wheeler or something. Glider is nothing but the chassis, the wheels, the bodies, the okay, all those mechanical parts, handles and all those things, lights and all those things, they remain, whether it is ICE vehicle or ICE is nothing but the ICE engine vehicle, okay, whether it is a petrol diesel vehicle or it is a EV, those things remain same. So glider part remains same, whether it is ICE or EV. Only the EV powertrain part I'll be okay briefly touching upon here, okay, just for explanation purpose. So major one is the important one is the battery, okay, which cost around 40 to 60% of the vehicle cost based on your range capacity and other things. So this is one of the most important part. So what is battery? Battery is basically from an ICE vehicle. If you take, it is replacing the fuel and fuel tank. Okay, so it is a source of energy to the vehicle. So it basically, if you take the lead acid battery, that is very well known to us. Okay, because it is used even in the auxiliary loads for that one. Still, we are using lead acid battery. But that battery, because of the larger size, its density is very low. Because of that, okay, it cannot be used in the EV because you will get a very less range. Instead of that one, we are going for the lithium-ion batteries. And in the lithium-ion batteries, particularly the NMC, nickel, manganese, cobalt, and LFP. Okay, so LFP is okay, iron phosphate, okay, cobalt battery. So those two batteries are becoming very famous in India, okay, particularly LFP because of it is a better temperature operation, and NMC because of the higher density. Both these batteries are having instability, unlike the lead acid battery. Lead acid batteries are fairly safe. When you charge it, when it is empty, it takes a lot of current. When it is fully charged, it reduces current by itself. And it remains same. Even if you keep on charging, it will not draw any current and it will be safe. Unlike that one, the lithium-ion batteries are unstable. When both the conditions, when it is fully charged, if you don't stop charging, it will become a hazardous state. And during when it is complete discharge also, if you don't stop taking energy from it, then it will goes to instability. So in both the conditions, it goes to hazardous situation. Hazardous is nothing but it may fail at that time. It may, okay, failing can be a thermal problem, it can be blasting, it can whatever, multiple failure hazardous situations are there. So when it is fully charged and in fully discharged, in both the conditions, it can go to hazardous situation. Because of this, a very efficient and okay, what you can say, a fail-safe battery management system is required. Okay, so BMS is mostly associated with these lithium-ion batteries, not so much with the lead-acid batteries. So what BMS does is, basically it does two functions. That is just for remembering purpose. One is the controlling this battery, the charging and discharging conditions. When it is charging, it continuously monitors, and fully charged, then it stops charging. And during discharging, it continuously monitors. Once it reaches the knee point or the energy available, it's over, then it stops discharging. It will give an alarm to the operator, driver, and the driver has to take care that he has to go for charging or stop the vehicle. So these two conditions, critical conditions, it manages. The third one is most important one. Okay, these two conditions, basically this is charging and discharging. This is the first one. And the second one is the cell balancing. Because in you might have seen already that the batteries are connected. So many cells are connected in series, parallel, and all those things. And multiple cells are connected in series. One cell in LFP is having 3.2 volts, and in NMC it is 3.65 volts. To get a 48 volts, you have to connect okay, so 13, 14 cells in series, and for 72, you have to connect 23 cells in series. Similarly, for NMC, you have to connect them in so many in series. Once you connect them in series, what happens? So the current has to flow through all these cells. If one of the cell is weaker, then that cell charges faster and does not allow other cells to charge completely. Then during discharging also, it discharges faster because it is weak, and it will not allow other cells to discharge. So what happens because of this, neither you will get a full charge during charging, and during discharging also you will face problems. So during charging, what it is done is it is process called cell balancing. In cell balancing, what it does is that once the cell is charged, because normally because of the safety requirements, once one cell is charged, then you have to stop charging. Once the charging that is done, then you balance it out. This whichever is charged cell, its energy is distributed to the other cells, so that all the cells becomes the same. Again, you can charge it. So like that, you can hold lot of energy during discharging. Also, this will help. So these two functions, one is the controlling of the battery during charge and discharge modes, and then the cell balancing. These are the two functions, important functions this battery management does. Next comes the chargers. Okay, so there are two types of chargers. One is the onboard charger. Onboard charger is nothing but the charger is put into the vehicle. And then the next one is the offboard charger. Why these are two chargers? Onboard charger, there is a limit. You cannot have a large charger onto the vehicle because of the space constraints. Basically, charger is AC to DC conversion because the power is available, grid power is available in AC form. It converts into DC and controlled way, it charges the battery. So because of that limitation of the space, there is a small onboard charger is put. Normally it is used for overnight charging or the slow charging in the vehicle. If you want to charge the battery faster, based on the battery, it is subject to the battery C rates available. Okay, you can have a fast charger. You can directly charge with a fast, wherein you can put this large charger outside of board and take directly DC and charge the battery. So it is based on the C rates and also based on the condition of the battery. You can charge the fast charge. Fast charge, not necessary that every vehicle can be fast charge, because it is some batteries will have only 0.5 C charging. C is nothing but, if it is normally batteries are defined by their capacity in terms of AH, ampere hours. So 1 C is nothing but in 1 hour, it can be charged 100%. So many amperes it takes in 1 hour. If it is 0.5 C is nothing but it requires 2 hours of charging. If it is 0.3 C is nothing but it requires 3 hours for charging, full charging. So based on the C capacity, you can put a off-board charger, and if it is having consider a 2C or 3C, you can charge in 20-30 minutes, and then you can use a large fast charger and directly charge this battery. Okay, then next comes the important one is the drivetrain. So this is called traction inverter. It is having motor controller, and the transmission. Normally transmission is nothing but a gearbox. Unlike ICE engines, there 3, 4, 5, 6 ratio transmissions are there, gears are there. In EVs, normally it is a one ratio gear. Whatever in most of the Indian vehicles, we find one ratio, and some of the goods carriers we find two ratio transmissions. This is a motor, and normally we are using in India three types of motors: a BLDC motor, an induction motor, and the PMSM motor. Normally in the lower end vehicles, whatever you see in the two-wheelers, particularly two-wheelers and rickshaws, you find BLDC motor that is running around. So the hub motors, whatever you find, that is maximum RPM is around 1000 RPM, and they produce up to 100 to 120 Newton meters, very low speed one, and they are connected directly to the wheel. And they are used in the mostly in the two-wheelers. Most of the scooters you find today with the hub motors, and they are all BLDC motors. In mid-mount motors also for rickshaws, up to 3 kilowatt, you find the BLDC motors. Over that, then you are having the PMSM motors. And in between this PMSM and the BLDC, there is an induction motor also. Induction motor advantage is it is highly reliable, very low cost, but the penalty is that its weight is large and efficiency is low. Compared to the BLDC, PM, and the induction motor, their efficiencies are more or less between 88 and 89, less than 90%. The PMSM efficiency is somewhere around 93 to 94%. So very high efficiency, but it is expensive, and you can run at a very high RPMs. So this is the drivetrain, these three. Okay, and next there is a small part. It is a DC-DC converter. Basically, you might have seen in your vehicles, ICE vehicles, there is called magneto, or some people call it dyno. It basically converts the mechanical RPM, mechanical power of the engine to electrical power for the low voltage operations, all the auxiliary loads. Normally, auxiliary loads are operated at 12 volts. And this magneto, because here in the battery already we are having a high voltage. So this just convert from high voltage DC to a low voltage DC. That's why it is called a DC-DC converter. So these are the parts. Otherwise, this HVAC and cabin heaters, they remain same like a ICE engine, nothing. So there is a battery, there are chargers, there is a traction, one inverter, this is a drivetrain, and the DC-DC converter. Only these four parts in an EV, nothing complex, very simple. Okay, I'm moving to the next one. So here, there is a, there are, this architecture, communication architecture is basically taken from for a large vehicle, like a four-wheeler, established four-wheeler, Europeans, Western countries, and Japanese, those kind of larger vehicles, because already there is a vehicle which is having its own CAN bus running. All those whatever called ABS, EPS, the body control modules, the HVACs, the tire pressure monitoring, airbag ECUs, all those ECUs, infotainment, everything already it is there in the ICE vehicle. Already it is established one. So you can put your part to that network itself, but already it is loaded. Instead of that one, you can have a separate your CAN line itself. So you can create one more separate line. This is a vehicle CAN, which is already available. It is a established one. You can have a EV CAN, separate one, wherein all your the motor controllers, the BMS, the charge control units, the onboard, offboard chargers, DC-DC, even all those things, whatever the additional things you can put here. And then they can be interlinked with the EVCM, or it is called VCU, or then you can take a gateway to take the data outside. So this is a global architecture, communication architecture of a established vehicles. So I am moving to the next one, which is an interesting one, which is for India, for our own, because this kind of okay. In Indian vehicles, what we find is that a fairly simple EV architecture, right? Because EVs are emerging with okay, in the smaller vehicles, particularly the two-wheelers, the three-wheelers, okay, e-cards, and all those things, and up to what you can say L2, L3, L5, up to L7 and N1 kind of a category of vehicles. So in those vehicles, having two CAN communications doesn't make any sense, and okay, they don't have big body controls and other things as well. So there will be a single network, and okay, so exactly same one, whatever we had CAN network vehicle, okay, the EV network. So same EV network here. There will be one more part here which is missing here is a cluster. So just to add a cluster to it, it becomes a complete EV communication architecture. Now, what is happening with this limited communication architecture itself in India? Okay, there are some connected features are being offered. So many connected features being offered. So so you can monitor more than 100 parameters. So what is happening? So with this telematics gateway connected, you can get almost all the parameters: battery voltages, battery currents, okay, all the battery temperatures, even the motor okay, torques, and all those 100 critical parameters you can monitor. You can monitor the speed, location of the vehicle, SOCs, basically state of charge, okay, distance to empty, how much energy is available in the vehicle. Those things also you can remotely monitor. Okay, and then you can vehicle health status also you can get it. Then also, then you can do a lot of analysis, usage pattern, how I am driving the vehicle, or somebody else is driving the vehicle. Okay, so how the energy being utilized. So then how many cycles battery is charged, discharged. Root cause analysis also we can do. Then we can do a lot of prognostics and diagnostics analysis as well, because OTA is available over the air, because this is a connected vehicle. This is a CAN is available, and with the telematics gateway, you can have the OTA over the air facility, wherein you can do a lot of okay, updates and other things. Any new thing comes, then we can do that updates. Digital twin is one of the very famous nowadays, famously used for remote verification and validation of the vehicles. So consider I am sitting in Hyderabad, and okay, our vehicle is running in Delhi, okay, and their weather is cold, and based on that one, okay, we can modify those parameters of that vehicle, and digitally I can see what is happening to that vehicle, and accordingly I can tune that one, and even seasonal wise, and okay, all those things can be done. That is called a digital twin, and you will be having a equivalent vehicle okay, located in your place, and your vehicle is running, consider in some remote place or some other locations in okay, other country as well. Then you can accordingly tune that one and make it optimal okay, operation. Then you can identify also component degradation and all those things. Consider motor is heating up, then you can identify. Consider a battery cell is degrading, that also you can identify very easily, with so many algorithms are available. And then you can do the remote diagnostics as well. Okay, so with this one, I will okay, change to the our main topic of EV evolution. Okay, if any questions, any clarification is required, just you can ask me, but I am not able to see the chats rather. Sorry for that one. Okay. Yeah. Okay. Now what I am doing is I am going to the okay. Basically, I'll taking you through the evolution, how the automotive industry has evolved, and what technical challenges EV is bringing, and what is its future. Okay. So what is happening? This is a glider. Okay. So we know that this is the ICE engine. Okay, everything you can see the parts. Okay, Hanan, you can mute it, please. You, if you are having question, you can ask. Fine, thank you. Okay, so this is a ICE engine. Okay, you can see all the parts here, and this is a glider, whatever I referred as a glider. And most of these parts are mechanical parts. And this was a established technology, matured, reliable, safe, everything was there. Okay, so working fine. Okay, so no challenges at all. Okay, you might have seen 65s and okay, whatever in okay in the old these ones, all these vehicles are okay running fine. Now what has happened to this vehicle, just you can see here on the right side. So many electronic controls have been superimposed to them. So you are having adaptive cruise controls, you are having a brake system control, then there are closed off clusters and okay, and I just mentioned that there is a gateway of transmission of data for this one, and then there is a door control, there is a window control, there is a glass control, and everything. Okay, even tire pressure monitoring and so many things. Okay, so airbags are there. So many controls. So a vehicle is completely controlled by electronic systems. So what has happened is that there is a shift has happened. There is a drastic shift has happened because this left side technology got matured, and there is okay, it is totally matured and established, and it is performing its okay, it is a durable as well. Now the whatever is happening is that so many things are getting added, and most of things are in the electronic controls. So what is happening is because of this, there is a paradigm shift is happening, and what is happening is that electronics and software are now decisive core competence areas of vehicle development and differentiation. And so because of this, the EV or the auto industry R&D itself, there is a paradigm shift is happening. So what is happening? Around 70 to 80% of all the innovations in the vehicle today, I am referring even ICE everywhere, every vehicle development is nowadays based on the embedded electronics and control systems. 40% of the price of the modern vehicle is because of the electronic systems. And maybe next year it may reach around 50 to 60%. I'm not referring the battery cost. If you add a battery cost, it is okay, totally different one. It is going up to 75 to 85%. So even without that one, so cost of this one, high-end vehicles are having lot of electronics. Then 50 to 70% of the overall development cost is in electronic controls units attributed towards software and firmware. Even in the electronics, embedded electronics, electronic controls, the software and firmware is playing an important role. Those who are working in automotive industry, you may be knowing that there is for automotive falls in fail-safe systems. Fail safety has come through from the aerospace industry. So that is nothing but wherever there is a human life is involved, okay, and whatever the system around is called the fail-safe systems. So in aerospace, safety is required, and then the railway transportation, and that is in that series itself, the automotive comes. So automotive also a fail-safe system. Even a battery fails, it can fail because any electronic system or any electrical, even the mechanical system will fail. When they fail, they should fail in a safe mode. That is nothing but it should not affect the life of the user, life of the driver. So that is called the fail-safe systems. So because of that, the lot of these ones are okay happening, and lot of controls are coming towards defining the fail safety of this system, and that is very simple to implement in mechanical, difficult to implement electrical, very difficult to implement in electronics, because a electronic system can fail in a, because it is having most of the discrete systems. Electronic system can fail. When it fails, it can be logical 0, it can be logical 1. Okay, if it defined system, every time it fails in 0, then we can define very easily. If it every time fails in a logical 1 also, you can define very easily. But if it fails, okay, we don't know in which state it will fail. Because of that, there are many challenges. And okay, so now coming to the okay EV. Okay, so EV has established. Okay, there is a definite evidence of okay EV. Okay, is established, and there are okay, this is taken from the Norway rather, and very soon this kind of charging stations everywhere you can find. And okay, uh, this is it has taken off, and it is moving very fast. But what has happened is that, so this evolution has brought a lot of challenges as well. So this is not okay. What we saw, the EV architecture was a fairly simple architecture and other things. But when you go in detail, you start understanding its challenges. So okay, but it has things have moved from mechanical system to the electrical to the electronic systems. So already I mentioned that mechanical safety is fairly simple than the electrical safety, than electronic safety. Now there are many challenges it is giving, and every challenge brings okay a lot of opportunities for engineers. So what are those challenges? Functional safety, because you are adding the high voltage to the vehicle. More than 50 volts, 48 volts normally it is, more than 50 volts is hazardous to a human. Okay, and more than 60 volts, we need to go for the isolated architecture. Up to 60 volts, you can go with a non-isolated architecture. So those who are from electrical electronics background, okay, it is simple. That isolation is nothing but there is a high voltage, there is a low voltage. Okay, all the auxiliaries are running on the low voltages, all your lights, okay, whatever the control systems are we referred, the all those are running on the low voltage 12 volt systems, but the battery is operating at a high voltage. So up to 60 volts, it is not necessary to have them isolation. You can use a common ground, both the low voltage as well as the high voltage. Okay, so up to 60 volts, it is not so much hazardous to the human. Once it exceeds 60 volts, then it becomes a hazardous to the human. So it becomes a unsafe to have a common ground. So you have to have a separate ground. So that is called a isolated architecture. So there are, it adds, okay, this is I'm referring at a low voltage, but globally it has gone to 300, 400 volts. In buses are running at 600, 800 volts, up to, okay, even 1000 volts they are running. So there is a high voltage. So it is bringing a functional safety requirements. It is bringing. I'm having one slide. I'll refer that one later. Then independent systems. You have seen, okay, there is a in the communication architecture that there is a one on the vehicle network, and then one on the EV network, and one on the, okay. So there are multiple independent systems, particularly if it is a hybrid, then they are having multiple. You are having a ICE vehicle as well, and ICE powertrain as well as the EV powertrain. Then multiple voltages. Already we know this one, that battery voltages are higher voltages, then okay, auxiliary voltages are lower voltages, multiple voltages in a same system. Then we need to have packaging. Okay, all these things need to be packaged. Okay, consider particularly in the hybrid systems wherein already your IC is congested, and over that one we have to put battery, we have to put so many things. Okay, the powertrain parts, the drivetrain, chargers, DC-DC converters, and so many. Packaging also a challenge. Particularly with the large batteries, because everybody wants to have a larger range, and they need to have, for that one, they need to have a larger battery. Once you spread the batteries, then the space for other parts becomes, okay, congested. Then the virtual verification. Already we know that the digital twin, what is a digital twin? Virtual verification. Consider vehicle. I'm sitting in from Bangalore or Hyderabad. I can do the verification of a vehicle, which is anywhere in any other place or any other country as well. So that is what is digital twin and virtual verification. That also adds to a lot of challenges. Then the weight increase. So yeah, many people we initially we guess that EVs may be lighter than the ICE vehicles. No, it is a reverse one. Okay, because the batteries all always like a full tank, and okay, with a full fuel. Okay, and the larger tank with the full fuel rather. So okay, always they remain with the full weight. And because of that, everybody expect a larger range, a larger battery. Because of that, the weight of the vehicle goes up. So these are the challenges. So next is the, you can see the left side, the low voltage. Okay, this is the harness, and the harness becomes highly complex, highly complex. And right side, you can see the EV harness. Okay, because literally it is very complex, and it is having high voltage cables, it is having signal cables, it is having control cables, then a lot of communication cables. And also it adds to a lot of EMI, EMCs and all those issues, because so many cross couplings and other things. So this is a huge challenge for the, okay, the wiring harness. So then this is a electrical integration. It is a, because it is a huge challenge. Electrical integration. You can see here lot many, or okay, cables here with power cables. All oranges are the power cables. Okay, and this is a battery, and then the front one you can see the motor controllers, and the backside one the chargers and other things. Very complex. Over this you okay sitting and arrangements. So it is a very complex integration. Okay. Yeah. Okay. Then comes the functional safety. So what? Okay. Already I okay briefly defined what is functional safety. Okay. Basically, safety is nothing but any hazardous situation. So the hazardous situation is possible anywhere, any place, any mechanical system, electrical system, electronic system. But when a hazardous situation comes, it should be controlled in a such a way that the human around is not affected. Okay, so that is a hazard. So here hazard is in EV is a risk of electrocution. Okay, a person can get electrocution. So that is a hazard. Okay, what is the safety goal? So whenever this okay, reduce the risk of electrocution to the acceptable level. So that is nothing but try to see that there is no electrocution is to the occupier or the user of the vehicle. What is the functional safety requirement? Vehicle shall shut off the high voltage. Okay, high voltage is the one which electrocutes. So you have to shut off the high voltage system if any error is detected or connector is removed. Okay. What is how the technologically you have to implement? What is the technical safety requirement? Vehicle shall shut off the high voltage in case of error is detected, or high voltage connector is opened or removed. Removed even somebody is removed as well. What is the system requirement? High voltage electrical system shall have a hardware mechanism. So how to implement this one? So that is nothing. What it is saying is that you need to have a hardware mechanism in case of any high voltage supply can be disconnected or any connector is opened, then the hardware system should take care that the HV is disconnected. And that is possible by using a hardware interlock system. That is the hardware safety requirement. So like this, all these systems need to be implemented. Okay, but unfortunately in India, Indian vehicles, we don't have any of these safety requirements. Okay, and the initial whatever the two-wheelers launched were not having any of the safety requirements. Okay, and because of that, we had lot of fires and other things. And now with the AIS-156 is coming, and AIS-156 is forcing us to implement all these safety requirements. I'll briefly touch upon the AIS-156. Okay. IP67 ingress protection. IP67 ingress protection is nothing but it should have both water and air should not enter into the battery. That is the IP67. First, okay, basically ingress protection IP stands for, and 6 and 7 for the air and water. And then what is saying is that the next one is a microcontroller based BMS. Battery management system. Okay, initially whatever the vehicles we saw on the road, okay, 2-3 years rather, and they didn't had any microprocessor based BMS. There was a hardware BMS, and it was not having any control and communication features. What it was doing is like a lead acid battery. Whenever voltage goes up, it was switching off the charging. Whenever voltage comes down, it was switching off the discharging. So that was okay, it was doing. So it was hardware based. So now it is okay. What okay, AIS-156 is saying that it need to be a microprocessor. It need to be an intelligent one, effectively. So BMS need to have EMI EMC compliant. Okay, so it has to comply the EMI EMC. Okay, we saw that one complexity. Because of that, we have to have EMI EMC compliance. And then BMS has to have protections, all kinds of protections: over voltage, over current, over temperature, then overcharge, over discharge, all kinds of protections it need to have. Then 6.1.3 onwards, there are up to G. I have put a different color. These are charger related, very critical one. Battery and charger are linked together. Okay, so they work together. So overcharging protection via power cutoff. Okay, already I mentioned you at the beginning that the lithium ion batteries are unstable when they are fully charged, and once they are fully discharged as well. So this overcharging protection, what it does is that once it is fully charged, if you don't switch off the charging, then it will go to a hazardous situation. So what this AIS-156 6.1.3a is asking is overcharging protection via power cutoff. If it is overcharged, then you have to detect and cut off the power. The next point is overcharge protection through timer out. So in case of power cutoff fails, then you need to have one more redundancy. That is a fail-safe redundancy based on timer. Consider you are charging for 1 hour. You have put a charging for 1 hour. 1 hour, you know that it is charging for the 80% or 90 or 100%. After that, you should give a time. Okay, automatically system should cut off. Whether even BMS is detecting, whether charger is detecting or not, you should have a timer based. Timer based, you can put a relay in series, and that timer will operate and it will switch off. So this is a redundancy. One is BMS will take care, other is the charger will take care on the power cutoff. The third one is a timer based. Then the charger need to have a soft charging. That is nothing but initially it should not take more current from the battery, because that is called inrush current. You should avoid drawing inrush current because battery will fail. Then pre-charging with under voltage condition. So this is one of the critical requirement. Those who are from EV, they understand. If battery is fully discharged, then you connect it to a charger, then it draws very large current. Okay, so it should detect, charger should detect that this battery is fully discharged. Okay, and then okay, based on that voltage, it should have a pre-charging. Pre-charging is nothing but till the voltage is rise, it should give a lower current. Then it can go for the normal operation. So that is called pre-charge condition. Then voltage and current regulation and fluctuation. Voltage and current, okay, we have to regulate both voltage and this one. Then the next one is earth leakage detection. This was not there. This is to protect the human. Okay, basically it is a RCD, residual current detection. Okay, we have to add a residual current detection. It is having two kinds of circuits, not sure, okay, how many, okay. So it is having, one is 30 milliampere current and other is 60 milliampere. You can have either of the, there is no restriction. You can have a 60 milliampere, which is cheaper one. 30 milliampere is which is a little expensive one, but you need to have a earth leakage detection. In case of this earth leakage is happening, then system should stop charging. Okay, because any 60 ampere and 60 milliampere and above earth leakage will be harmful to the human being. So communication of charger with BMS. Now the AIS-156 is mandating that BMS and the charger should be intelligent and they are communicating each other. BMS should communicate to the charger should communicate, and based on the BMS condition, charger should start charging, and once it is fully charged, then BMS should communicate to the charger to stop charging. So those are the ones. Okay. Next one is the thermal propagation. This is also one of the additional one, and this is an important one. If one of the cell fails because of the thermal, this one, it should not propagate to the other cells, adjacent cells, and adjacent should not fail. So that is the condition. So you have to design battery such a way that even if one fails because of the thermal or some reasons, one cell, and it should not propagate to the other. Okay, risk of bias, okay, bystander mitigation. This you know it. The bystander who is standing, okay, close by the vehicle, he should not get affected. Okay, and functional system diagram need to be produced. Okay, that diagram nobody was producing. Okay, then need to be thermal propagation test need to be done. This is up to 300 degree. You have to do the testing. Okay, then last one is the audio visual alarm. So in case of any thermal issue is happening in the battery, it should give an alarm. Okay, it should be audio, it should be visual as well. Right now, consider if battery something is happening, then it should create an alarm sound or something to the user so that he can stop the vehicle or move away from the vehicle and save himself. Okay. So next one is okay. Continuing with this one, AIS-156. Okay. So now every manufacturer has to put the date, month, and year on the cell. Every cell need to have this one. So whether it is how many year old or all those things can be identified, and this cell need to have a cell test to be done by accredited lab rather. And file cycles per cycle of C/3, that is 0.3 C rate. You have to give the store the data pack details by the manufacturer. Just 0.3 C charging and discharging 5 cycles one has to do and to store this data. For your vehicle, any of this vehicle you are buying, and this data you can inquire with the manufacturer. Pressure release vent need to be there in the battery pack. Okay. And minimum you need to have, these are all two-wheeler, three-wheeler I'm asking. I'm referring here, the light vehicles. These are all 48 volt, 60 volt, this ones. In many of the places, even the temperature sensors were missing in the battery packs. Now the AIS-156 is mandating that at least 4 sensors you need to have the temperature sensors. Earlier days when the batteries started coming in the market, I'm referring 2014, 16, 18. At that time, every cell used to have a temperature sensor. Every cell used to have a voltage sensing, and every cell used to have a temperature sensing. But those were reduced and literally they were missing. Now at least 4 cells have been mandated here. And active paralleling, again, one of the critical requirement here. Active paralleling is nothing but when you are using a single cell in series, no, there is no paralleling of the cells. Because for the higher power rating, you need to parallel them. You need to put some cells in parallel. Once you put cells in parallel, one of the cell fails, then it should not create a problem to the other one. Okay, one cell can fail, but once it fails, it should isolate itself. That is called active paralleling. So we need to have an active paralleling concept put into that one. Then we need to have a proper cell spacing in between, provide a fuse, okay, and have a traceability document. RESS is basically the rechargeable electrical energy storage system. It is effectively battery. It is battery is called RESS. So traceability document need to be created by the manufacturer. And protection during regeneration. Okay, in a EV there is a regeneration. Regeneration in a we can go up to 20% of the power you can regenerate, but during regeneration some of the vehicles don't have protection itself. So that protection need to be put. And BMS need to have a data logger, and BMS need to have a RF reading. So these are the AIS requirements. If any information is required here, or I can take your questions. Okay, so with this one I am closing my presentation. Thanks.
Jazakallah, Dr. Saab. Okay, now we are open for questions from the audience. Do you have any clarifications or any discussions you want to have with the expert? Any questions?
Yeah, thanks. First of all, thank you very much, sir. It was a nice brief introduction to the EVs. This is Ghulam Ghosh. I have one question regarding this.
Ghulam bhai, can you please introduce yourself so that sir can understand the background?
Yeah, basically, I am a mechanical engineer, but I am working with the EV operations in Tata Motors.
Okay.
Okay. So, first of all, thank you for your lecture, and just I wanted to ask two, three questions regarding the range anxiety that the people are having in their mind. How we can come up with that? Because as of now, the customer are new to this EV business and they are not well set to the behavior of the vehicle as well as their behavior regarding to the driving and charging discharge pattern, that is also affecting the range. So what we can do to educate the customer on the range side?
Yeah, good. Yeah. Okay, thanks, Gulam bhai. This is a very old question rather in EVs, and okay, so it has more or less it is now it is resolved rather, because with these new vehicles, whatever we are particularly in four-wheelers, okay, what we are seeing is that the ranges are more than 400 and some are giving 600 miles rather. Okay, so those in the larger countries and those established ones like Teslas and other things, they have taken out the range anxiety at all altogether. But of course, in Indian vehicles where the batteries are smaller, our vehicles are smaller, range anxiety is still prevailing. So in Indian context, the government is coming up with a solution to the range anxiety is through the swapping. Okay, so battery swapping already standard have been okay. Draft standard has been released, and these are those batteries. Those things are working in parallel. Okay, and that is taking off. Okay, Niti Aayog is putting a lot of pressure and to implement that one. That is happening. That is one side of okay, this one. And with respect to the technical range anxiety, okay, only we have to see that uh, properly this okay, we batteries are intelligent, and with the BMS data available. Only thing why range anxiety is coming, if the data shown on the cluster is not correct, and consider now okay, data SOC is shown as a 60% and actual energy available is only for 30 or 40%, then the range anxiety will come. What happens, that fellow will drive and somewhere around 30% or 20% of vehicle will stop, then that creates a lot of range anxiety. So that need to be taken care, so that auto calibration of the SOC need to be done, because what is happening, particularly when you are having a HVAC and other loads running, and sometimes those loads are not considered in the SOC calculation, particularly DTE calculation, distance to empty calculation. Okay, and that need to be accurately considered in the discharge energy. And one more point I want to make it that as you use the battery, okay, what you can say, the not full cycles, partial cycles. Consider I am charging 60%. Tomorrow I charge up to 40%. Day after tomorrow charge up to 70%. I never charge up to 100%. This partial charging, Glambai, this adds to the error. Okay. So what happens once you do this one continuously for 8-10 cycles, then your error is accumulated, and that error creates a okay, data shown in the cluster and the actual data, there is a error. So for that one, what you have to recommend to for them to, for every 3-4 cycles, let them charge 100% cycle. Okay, keep the battery charging for the complete overnight something. So that will help.
Yeah, thanks. Thank you, sir. And one more question from my side, that is the serviceability of the EV vehicle. Actually, nowadays, whatever the customer we are having in the market, they are from the some different terrain and all these things, and everybody is not accessible to directly to dealership at 20-25 kilometers. And there are certain problems like limp mode and rightly you have mentioned that SOC and all these things that causing the cluster error. Sometimes there is a limp mode activated on the cluster, and people are getting panic, or some people are ignoring that signs of the vehicle that giving the alarm that you need to take care of your vehicle, but still we are not in a good position to service the vehicles in the field at all regions. So that's why the OEMs are trying to uh, restrict their market to certain urban cities and not going to the rural one. So for that, it is not easy for a local mechanic to service these EV vehicles, is it causing a slowdown for the sales of the EVs? As maybe it is applicable for four-wheeler at much extent, not for two-wheeler and three-wheelers.
Yeah. Yeah, but you already mentioned that one, because for four-wheeler, okay, this is a problem in India because that market is not yet taken off, rather, it is not yet matured to an extent that wherein, okay, we can put the service centers and dealers everywhere. That is not at this one. And also, it will take some time. Okay, right now, what is happening in two-wheelers, it is established more or less. A smaller two-wheelers, you see, okay, there are a lot many dealers every city, everywhere, even in the tier 2 cities also, we are finding them. And right now, there also repair is not being happened. Okay, now unlike ICE engine vehicles, here repairing is not done, it is only replacement is done. So because of that, fear is there that it cannot be managed. But what I am thinking that it is just a matter of time that the repair and service network will come. This may not come through the dealership. This may come through young people, those who come from graduation or something. Once they start getting vehicles, more number of vehicles. And for the four-wheelers you referred, it is very difficult because only you can have a proper remote monitoring and diagnostics, and that only can help. Otherwise, it is a difficult one. And right now, servicing is not yet matured. It will take time.
Thank you, sir. I will ask one more question, but let the other people get a chance. If there is nobody, then I have a last question regarding the cost of these EVs, because as you rightly mentioned, 60 to 70% the cost content is regarding battery, e-drive, EDU, and DC-DC chargers and all these things. Did you see any future technology which can help to reduce the cost so that it could be comparable with the ICE vehicle cost?
Yeah, no, that thanks for this question, rather, because this trend was there in 2018-19. That trend was there because more or less the battery cost reached 2021 to $100 per kilowatt hour. But now it has taken a U-turn. It is going up, rather. So I don't think that this one will come. Parity was supposed to come in 2022 itself. Okay, and the cost has come down, but the other cost, the drivetrain cost, the charger cost, the DC-DC converter cost, everything has come down drastically. Okay, and only the battery we need to have somewhere around $90 or $100, but now recently it has gone up, rather. So that because of that, the parity did not come. So not expecting very soon that will okay. But if the battery prices comes down to $100 or below, then definitely it is possible.
Yeah, I agree with you. Maybe the localization of this battery cell manufacturing could help.
Right. Yeah, with our own lithium and other things coming, and that may come much faster. And with that one, we should be able to handle. And also, government has brought a good policy wherein we are giving a lot of subsidy to the recycling companies. Okay, battery recycling. Right now, a lot of recycling is happening with this mobile lithium-ion cells. And therein we are recovering all those lithiums. We are not sending. Earlier we used to send to South Korea and Netherlands and all these cells. Nowadays, government has given a lot of funds to this Ludhiana batteries, Coimbatore. There are many recycling battery recycling companies have emerged, and almost all the cells are being recycled in India. And lithium recovered is also very good one there. So whatever, even electrode recovery, all those things, and they are being reused. So that will happen soon. So with that one, the battery cost may come down.
Thank you, sir.
Assalamu alaikum. My name is Fauzan.
Yeah.
Just out of interest, I'm asking this question.
Fine, sir.
What's the proportion of that? Means the battery cost not going down means it is the cost of the raw material that has gone up, or it's some technology monopolistic attitude of the manufacturers that is working, or the raw material scarcity is the fear that is creating this thing.
Yeah. Yeah, I'm not sure whether Fauzan Saab, whether I will be able to answer the perfect one here. But initially, China was pushing this EV market. Okay, if you take a decade back, they were the ones they wanted to. Okay, they were pushing, and they were rather wanted this EV market to grow, and they are the dominant ones in batteries and other things. And okay, from Korea, okay, it started from Japan and Korea, then moved to China rather, and they established themselves in the battery technology. And then they were pushing, and in 2016-18, till then it was what we have seen is that from $750 per kilowatt hour in 2010, $750, it reached around $200 in 2018. Okay, so a drastic reduction, for nearly 4 times the cost reduced. Further from there, it is not reducing. Everybody expected further it will go down. It is okay. So it has come to around $120, $130 somewhere, and from there again it has gone up. Maybe it is a material, sir. Okay, because it is the usage has increased, and now countries started controlling the material.
Okay, you mentioned something very interesting about recycling.
Yes.
So what it takes to put up a recycling plant, and who are the players, and is there any mechanism that you are collecting these dead batteries of mobiles? Means that can be can that be a MSME industry? Can it evolve to be an MSME industry? So that is another question from the for everybody's interest, so that people can explore, and even if I am not doing it, I'm just opening it up for you to give suggestions or for you to impart knowledge.
So that government of India brought a good policy, particularly in EV, that there is a what you can say. Niti Aayog made a consortium wherein the OEMs, the cell collectors, and the cell recyclers, okay, are the part of that one. So that's why this you might have seen in my presentation also, that every cell has to have the identification. Okay, and once it goes for recycling, what they are saying is that those who are taking cells directly to the recycler, that is the left to the users. But normally in India, what happens? We give vehicles back to the OEMs. And then it is OEM's responsibility to collect those cells and give it to the recycler. And there is this one. And this industry, surprisingly, in 2016-17, okay, a lot of funds have come to them. And particularly for our community, this is a very interesting opportunity. And there is a government funding also available. And this industry is not making any loss at all. From day one, they are making profit. And yeah, that's what I can tell right now. And for help, IIT Madras, Professor Junjunwala, we can approach, and he can provide all the 3-4 industries. Those have come, they have come through Professor Junjunwala.
Are you aware of any industry in Karnataka or in Bangalore that would have been that would have come up, so that somebody can have a reference or do a site visit?
Yes, sir, I am having, but right now not coming, but I am having those details I can share. Okay. So my number is also available with, okay, here, and otherwise also my number I can, okay, collect my number and I can share you, sir, later. Okay, you can share me your number as well. I'm having details. I'm having 3-4 one is there in Bangalore as well, and one is there in Coimbatore, and one I have Faridabad. Okay, Faridabad is the old one. So all these details I can share.
Okay. I would request Mr. Saif to put Mr. Allabaksh's number on chat.
Yeah.
Yeah, I'll be doing it, inshallah. Okay, do we have any other questions from the audience?
Yeah, Assalamu alaikum. So myself Farooq Ahmed. So it was very interesting topic, though I'm not a background from this automobile, but I have came to know some new things and new terminologies. Like if I, as a user, if I have to buy EV car in the future, so definitely there are some points, interesting points that are especially covered, like AIS-156, those things that I can look. So a couple of questions that I have from my side. So if I have to purchase a EV vehicle in India, or if I have to suggest someone, so as per your expertise, so would like to know how Tata would be, or the Tata Nexon vehicles, or any other vehicles that you think where some of these are better facilities are there coming to safety. And the next question is like mostly if someone was buying vehicles nowadays, they are directly installing some plugins, or people who are renting and the apartments, they are doing some installations, quick installations. Then what are the precautions that we need to consider?
Yeah, first question is fairly simple. Right now, Tata Nexon is established and they are doing good. And okay, we can go ahead with that one. Okay, so there are no issues at all. And that is a 400 volts technology, high voltage technology, matured one. And Tata Technology Group is also, earlier it was most of the products were taken from China and other things, but now their Tata Technology is doing by themselves. They have developed all chargers, DC-DC converters, so many things they are working. And we can go ahead with that one. So that is a fairly simple question on that one. And then coming to the next one, is installing a charging station or a charge point in the apartments and in the homes. Okay, so what we have to do is that is a if the directly connecting to the grid is a riskier one should not do that one. What we need to have is that we need to have a small EVSC, what it is called, electric vehicle supply equipment. It is a standard available. And once you are buying that one also, you should inquire, because in India, they put EVSC on the box, but inside nothing will be there. You have to look into that one. Okay. So what it need to have is that first is it need to have a RCD, residual current detection. That is nothing but it need to have a earth leakage protection. Okay, and then it need to have a good contactor, and then over current, over voltage, and under, okay, those protections, okay, overload protections. So these are fairly simple one with one, okay, contactor will be there inside the UVSC. That will be preferred rather than directly taking power from the plug.
Jazakallah. Thank you.
Thank you.